Welcome to lecture 16, polymorphism. So, during the basic introduction, we saw what do you mean by polymorphism. Poly, which is nothing but many, and the morph is nothing but the forms. So, the entity will take the multiple forms, right. So, for example, a function, right, the member function or even a function that takes many forms. So, in C++ and Java, you have the polymorphism, right, the property of polymorphism. That means the properties of one class to be used in different class in various ways. So, you call this is polymorphism. For example, I have, let us say, a function int, right. So, maximum of int a comma int b. Assume that I am using this function, right. So, similarly, let us assume I have the same name, right. Assume that I have a same name, but here the parameters or the arguments I have float a and float b, right. So, in that case, in the main, right, what exactly you are doing in the main program, assume that I have written these two functions. So, let us assume I have a properly defined, the dot 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 is indicating that I have properly defined. So, in that case, which function will be called? For example, if I am passing, let us say, max of 2 comma 5 and I am storing this in some L, integer L, right. So, 2 and 5, since it is a integer, so by default, right, you have passed integer. So, this function will be called, right. So, 1, I put 1. So, 1 will be called and the resultant will be stored in L. Suppose I am passing, let us say, max of 2.5 comma 3.4, right. So, in that case, this function will be called, right, and whichever is the result, that will be stored in, let us say, float m, something like that, right. So, that means from this example, the entities can take multiple forms. So, here it is a member function. So, member function single entity means they are having the same name. So, the same name which is taking the multiple forms, right. One is you are finding out the maximum of 2 integers, or let us say you have a maximum of 2 characters, based on the ASCII value something will be printed, right. So, which one will be called? So, you call it as polymorphism. So, this is in the case of, let us say, procedural oriented language, right. So, in C++, Java, so since we have already seen the classes and also about the inheritance, right. Suppose class A, you have the function, assume that the same function, right. In fact, in the case of inheritance, right. So, we are going to call the concept as a overriding, we can have the same entities, right. Say name of the function and the arguments also same, let us say int a comma int b, a return type is also same, but the question is which function will be called, right. So, which member function will be called. So, now there are two cases. So, one I talked about the procedural oriented way, right, procedural oriented language way. Another one is, let us say, object oriented, C++ or Java, right. So, in this case, the first one, the compile time polymorphism, the previous example that we had seen, right. So, assume that without class we are writing this, I have written two functions of the same name, one is this and second one is this. So, this one, when I am calling this in the main, right, when I am calling this in the main, which one will be called? So, this will be decided during compile time, right. So, which function will be called? So, this will be decided during compile time. So, therefore, this is called the compile time polymorphism, right, or you call it as static binding or static polymorphism. Whereas, when we talk about the inheritance, right. So, base class you have the same function name, right. Let us assume the name of the function is int fun1 and then you are passing something, let us say integer comma integer, right. So, this is in the base class, and derived class also you have the same name, right. So, assume that I am defining this int fun1 int comma int. So, derived class also you have the same name, right. So, in that case, which function will be called? Assume that the functionalities are different, right. Function 1 I am putting cout, welcome to IIT Roorkee, right, and then here derived class I am writing cout, welcome to IIT Madras. So, in that case assume that the object is created under, let us say, the derived class, right. So, which function will be called? So, this will be decided during runtime. So, therefore, this polymorphism is called the runtime polymorphism. So, we already seen inheritance, the base class, derived class, and assume that the derived class is inheriting the base class, but the problem is you have same function name. So, in fact, one of the programs we had seen before, right. So, this will be decided during runtime. So, you call it as a dynamic binding or runtime polymorphism. So, as I said, in the case of compile time polymorphism, in C++ we can achieve this kind of polymorphism by doing function overloading. So, you can do function overloading. So, what do you mean by overloading? So, here as I said, the number of arguments, right. So, same maximum program, return type is integer, right, the same maximum. Suppose I have int a comma int b comma int c, right. We have already used what? Int, let us say maximum int a comma int b, right. So, one is maximum of 2 numbers, another logic we are going to write maximum of 3 numbers, right. So, now your number of arguments, here it is 3 and number of arguments here it is 2. So, in the main program when you are calling, let us say maximum of, let us say 2 comma 3, right, when you are calling the maximum of 2 comma 3. So, what will happen? This function will be called, right. So, maximum of 2 comma 3, 2 arguments, 2 values you are passing. So, that means this function will be called, alright. Suppose I am doing same max, let us say 20 comma 30 comma 40, right, 3 values I am passing. So, in that case this will be called, alright. So, there is a change in the number of arguments. So, during compile time it will be decided which one will be called, or like a previous example we had given the type, alright. So, type we had given float a comma float b and return type is also float, right. In that case it is completely different from the one you had written here, let us say 1, 2 and the third one is float, return type is float, same maximum function, but inside the argument you have float a comma float b, correct. So, in that case assume that you are calling maximum of 2.0 comma 3.0 or 20.0 comma 30.0, both are float, right. So, in this case you have different type of arguments, either number of arguments or different type of arguments, the third one, right. So, in that case whatever you are calling in the main, correct. So, which will be decided during compile time. So, therefore, this is called compile time polymorphism or static polymorphism or static binding, all are same names. So, let us see how function overloading is working in C++, right. So, let us consider area, right, let us consider area, alright, the name of the function is area, correct. So, you have one argument radius and area return pi r squared, right, 3.14 into radius, correct. Another function return type is double, alright, I have area, but there are 2 arguments, one is length and width, one is length, another one is width, length and width. So, now you are returning length into width, 2 arguments. Now, the third one same return type double, area, function name is same. So, you look at here the function names are same, right. So, here you have double base, height and triangle, right. So, now it is returning 0.5 into base into height, right, 0.5 into base into height. So, now you have, right, some radius 5.0, length 10.0 and width is 4.0 coming to the main program, base is 6.0 and height is 3.0. Now, I am calling the function area and then what I am doing, I am passing one value radius. So, when I am passing one value radius, only one value, so one argument function, so that means the radius will be passed over here, assume that what is the radius 5.0. So, 3.14 into 5.0 into 5.0 will be calculated and that will be displayed, okay, because this is a one argument function. And the second case it is a 2 arguments function. So, length and width, you are passing length and width. So, area function name is same. So, this will be called, this particular function will be called line number 10, right, you are passing length and width, correct. So, then length into width, what is length into width? 10.0 and 4.0, 10 into 4, 40, right. So, in this case 40 will be displayed, second case. And the third case same function name, but you are passing 3 parameters, base, height and true value, Boolean, right. This is what exactly is a true, is triangle is Boolean, and here you go, it is true. So, you are passing base and height, correct. So, it will be multiplied by half 0.5 into base into height, whatever you are passing, alright. So, 3 arguments you are passing, 3 values you are passing, it is a 3 argument function, correct. So, 3 parameters, and then the third function will be called, right. So, these things will be decided during compile time. So, therefore, it is called static binding or compile time polymorphism. The name polymorphism, because if you look at line number 25, 26 and 27, all the function names are same, right. So, therefore, this is called function overloading, or you call it as compile time polymorphism, or also you call it as static binding, right. This is the concept of function overloading, alright. So, when I run the code, I will get the output like this, right. So, these are the output you are getting. Area of the circle 5.0 into pi r squared, and then length into width 10 into 4 is 40, and off BH 6 into 3 is 18 by 2 is 9, right. So, all the output you are getting correctly. So, with this example, I hope you might have understood what do you mean by function overloading, or you also call it as static binding. Maybe one more example we can see, right. So, that the concept will be still clear, right. So, here I use volume. The last program we use area, let us assume, right, volume. So, here you have double side, right, the one argument. So, only one argument here you have, and then it will return side into side into side, a cube, right, one volume. Another volume, length into width into height. So, 3 argument, one is one argument, another one is you have 3 arguments, right. So, here what is happening? You are multiplying length into width into height, return length into width into height, and the first case return side into side into side, right. One is nothing but volume of a cube, another one is nothing but volume of a rectangular box. So, now the question is, I am going to use the same function name, alright. Maybe let us see if you have, yes, one more volume, alright. Here you have radius and height, 2 arguments, right. So, here first one is 1 argument, second one is 3 arguments, and the third one is 2 arguments. So, here you have pi into pi r squared h, right, for the cylinder, volume of the cylinder is pi r squared h. So, pi into radius into height, right. So, in all the cases, if you look, you have one function name. So, the function name is nothing but volume. So, let us consider your side is 5.0, length is 7.0, width is 6.0 and height is 8.0, alright, and the radius 4.0, 9.0. Now, volume of the cube. So, first I am calling with the one value that I am passing, right. So, that means it has one argument. So, that means obviously this will call line number 5. So, line number 5 you have one argument function, and if you look at line number 6, it is returning side into side into side, alright. So, assume that I am passing what? 5.0. So, what is the result I have to get? 5.0 into 5.0 into 5.0, correct. So, 125, that will be the output. So, you have only one argument. So, when I have only one argument, so the compiler will call line number 5, right, that particular function, and then it will return side into side into side. That means, it will return 5 into 5 into 5. 125 will be the answer. And line number 26, you have volume, this is one line, right. For our display point of view, I have written like this. So, you write it in a single line. When you are practicing this, you write it in a single line. So, volume of length into width into height, right, when you are calling the function volume, right. So, you are passing 3 values, So, that means, it has to call function with 3 arguments. So, function with 3 arguments, so naturally it will not go to line number 5. Function with 3 arguments you have at line number 10, right. Function with 3 arguments you have at line number 10. So, line number 10, if you look, it is length into width into height, right. So, length into width into height, that means 7 into 6 into 8, right. So, multiplication of these 3 will be the result for line number 26 and 27, right? You write it in a single line. And then line number 28, you are passing two arguments, radius and height, cylinder height, right? So, volume, again the same function name, you are passing two values. So, when you are passing two values, it look for two argument function. So, line number 5 is a one argument function, line number 10 you have three arguments. So, therefore, it will call line number 15, right. You have two argument functions. So, you have radius and height, correct. So, radius and height when you are passing, so pi into r squared into h will be computed and that will be displayed, right. So, this is how exactly happening. So, if you look at the output, first you have phi, so phi into 5, right. So, we are getting 125 as the output, alright. So, the second case, volume of a rectangular box. So, pi volume of rectangular box, it is length into width into height. So, 7 into 6 into 8, 42 into 8, right. You are getting 336, that is also right. And the third one is you are passing two values. What is that? Radius and height, cylinder height, alright. So, that means you are passing 4 and 9, 4.0 and 9.0, two argument function, right. So, two argument function in the sense line number 15. So, pi r squared h will be computed and you are getting the result like this, right. From these two examples, so now it is very clear that, right. So, when you are using same function name, right, more than once, and then it has to be different, either the arguments, for example, last two programs we have seen, the arguments are, number of arguments are different, right. If suppose number of arguments are same, their data type should be different, alright, also the return type, alright. So, these things we have to be very careful, alright. So, that is what the definition when I had given. So, number of arguments should be different or the return type should be different, or in the arguments if you are using the data type, that should be different, okay. So, then during compilation time it will be decided which function should be called, right. So, this you call it as compile time polymorphism. So, now theory is very clear and you had seen two different examples. So, what you can do, you can practice with some other examples, okay. And the next concept is dynamic or runtime polymorphism, right. So, what do you mean by dynamic or runtime polymorphism? So, here we talked about the compile time polymorphism. So, during compilation time which function will be chosen, alright. So, here in this case, since we had already studied inheritance, correct. Suppose you have class A, the class A has the same function name, let us say function 1, your dot 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 means you have defined something, and class B is inheriting class A, let us say publicly inheriting class A. So, that is also having function 1, alright. So, in that case which member function will be called, right. So, that is a challenge. So, this will be decided during runtime, right. The previous one it was decided during compile time, but in this case this will be decided during runtime. So, therefore, it is called the runtime polymorphism or dynamic binding, or you also call this as a dynamic method dispatch, right, dynamic method dispatch. So, several names, all are same, idea is same, alright. So, when which function will be called? That means it has to override some function. For example, the class B function is calling, right, it is calling the class B function. So, that means it should be overridden, right. So, that is called overriding. In fact, we had seen one example previously when we talked about inheritance. Anyway, we will consider the same example, right. So, method overriding, the meaning of method overriding. So, it is being done, right. So, when you have the base class and derived class, right, assume that both the functions are having, right, here you have a function 1, let us say return type is integer, and here also the return type is integer, both the return types are same and number of parameters are same. So, in that case one is in the superclass, another one is a subclass or base class or derived class. So, in that case when you are creating an object, right, and then when it is invoking, the object is invoking the function, so which one will be called, right. So, in that case the function should be overridden, right. Let us say assume that in the function in the base class is getting overridden, right. For example, this is being called You have created an object, let us say small b under capital B, alright. So, let us say you have small b under capital B. So, now this b is invoking, let us say fun1, alright. So, here in this case this function should be called. So, that means this function in the base class should be overridden, right. The function overrides the function in the base class. So, this function overrides the function in the base class. So, you call this as a runtime polymorphism or dynamic binding. So, what exactly happening in the case of a runtime polymorphism? Assume that you have class P, right. So, the class P that has in P, right, the class P you have one member data and one member function. So, that member function is displayed, right. You have another class Q which is a derived class which is publicly inheriting P. You have one member data Q and another member function is also displayed like your base class. So, now the point is when I am creating, let us say an object, let us say small q1, alright, under Q, and q1 is invoking display at one point of time. So, now the point is it has to override the base class and this function should be called, right, this function should be called. So, then you call this as the runtime polymorphism, alright. So, maybe we will talk about one example. Let us say you have class animal, right. Assume that you have class animal, animal is the base class and you have one member function called sound, right. So, under this function you have one print statement, this is a generic animal sound, one print statement, some print statement, and here in this case we have this is a generic animal sound and you have derived class dog, right. So, animal is the base class and you have a derived class called dog, right. So, it is publicly inheriting animal and then you have the same sound function, the member function is sound, you have the same member function, see out the dog box, see out the dog box, right. The class is over here and then you have third class, right, which is cat, which is overriding, right, which is inheriting, in fact which is inheriting animal, right, you have cat, right. So, cat also is having same function name sound, right, the cat meows. In the case of a dog, the dog barks, that is a see out statement. So, if you look at the diagram, all are having same name, right. So, in this case when you are creating an object, right, assume that I am creating an object animal small a under the class animal capital A. I have an object dog small d under the class capital D. I have object cat under the class cat, right, capital C. So, in these cases suppose the animal is invoking sound, alright, animal is invoking sound member function, alright. So, in that case you have three sound functions, in fact animal is the base class. So, base class you have sound, right, function sound. So, this member function will be invoked and this will be displayed first, correct. And the second case the dog object is invoking sound, right, the dog object is invoking sound. So, in that case what will happen, it will override the base class, right, line number 8 to 10 will be overridden. So, this will call the dog class void sound, this particular member function. So, in that case it will print the dog box, the second output you will get the dog box, right, and the third case cat dot sound, right. So, cat is invoking the member function sound. So, in this case what will happen, right. So, under cat, right, so this is a derived class, base class is this, the base class will be overridden and this particular function will be called, and when it is calling this particular function cat meows will be displayed, right. So, in the order it is getting displayed in this case, right. You can try in a different order, first put dog dot sound, correct. So, you may think it was initially going to the main, right, main in the sense base class, I mean to say base class, right. But in this case, so what is happening, if you look at the output, so these are all the output, right. So, the first one is the corresponding object calling to the corresponding class, second one is it is not calling, that is called the overridden, right. So, here you can see that, right. So, it in fact hiding the animals version, in the animals version you have the sound function, right, sound member function. So, that is not being called, right. So, this is what exactly happening over here, and when you run the code, you are getting the output like this, right. So, first one is for the animal case, second one is for dog, and the third one is for the cat, right. So, when it is taking many forms, right, when the entity is taking the many forms, you call it as polymorphism. So, under this we had studied compile time polymorphism, right, you call it as a static binding, or the example that we had just now seen, it is a dynamic binding, or you call it as runtime polymorphism. So, with this I am concluding this particular lecture. Thank you.